Hello students, welcome to Anne's classes. Let's do special types of quadrilaterals, chapter 17. Exercise 17, page number 203, question 11. In an isosceles trapezium, show that the opposite angles are supplementary. So here we have an isosceles trapezium, and what do we know about that? And in an isosceles trapezium, sides AB and DC will be parallel to each other. So let's mark that. These two sides will be parallel, and the non-parallel sides, these two are non-parallel lines because if you extend they will join at a point. Non-parallel sides are equal. So these two sides are equal. So what are we given? We are given that ABCD is an isosceles trapezium, and we have to prove in this question, we have to prove that the opposite angles are supplementary. That means angle A and angle C are supplementary, angle B and angle D are supplementary. So let's write that. We have to prove that angle A plus angle C is equal to 180 degrees. This is the first proof. And the second one that we have to prove is that angle B plus angle D is equal to 180 degrees. So we're going to prove this. So the proof here will be, we're going to prove the first one, that is angle A plus angle C is equal to 180 degrees. So these two are equal to 180. We're going to prove that. So that is the first proof that we are going to do. Now look at these two angles, angle A and angle B. They will be equal. Now how do we know that they are equal? They are equal because they are the base angles of a trapezium, and base angles of a trapezium are equal. So first let's write that angle A is equal to angle B. Now let's keep this as the first equation. We're going to make use of this later. So understand this, angle A is equal to angle B because they are the base angles of this trapezium, and base angles of a trapezium are equal. So we need to write that base angles of an isosceles trapezium are equal. That's the reason angle A is equal to angle B. Now let's look at these two parallel lines. Okay, so here AB we know is parallel to DC. Now if we take BC as the transversal, if we take BC as the transversal, then these two angles, that is angle C and angle B, will be co-interior angles, isn't it? So let me explain that once again. Now AB and DC are two parallel lines. Now if this is the transversal cutting the two parallel lines, then angle C and angle B will be co-interior angles. And what do we know about co-interior angles? They are supplementary. So let's write that down here. Angle B plus angle C will be equal to 180 degrees. And the reason is co-interior angles are supplementary angles. Now let's look at equation 1 that we have written here. So this is equation 1. Now this one, angle B plus angle C, we'll write this as equation 2 because we are going to substitute from equation 1 into equation B. Here we said angle A is equal to angle B here, isn't it? So in the place of B, I can write A because they both are equal. So if I write that, if I say angle A instead of B and I continue with this, it will be angle A plus angle C is equal to 180 degrees. And this is the first question that we had to prove, the first part. We had to prove that angle A plus angle C is 180 degrees. Here we have proved that. So we have proved the first part here, okay, proved. So the first one we have proved. Now let's look at the next one. So what do we have to prove next? We have to prove this. We have to prove that angle B plus angle D is 180 degrees. Now angle B is here and angle D is here. They are opposite angles, isn't it? That's the second proof, that the opposite angles are supplementary. So to prove that, again, let's consider the two parallel lines. AB and DC are parallel lines, we already said. Now this time, if we take AD as the transversal, so this time let's take AD as the transversal. So AD is the transversal. So in this case, Angle A and angle D will be supplementary. In this case, angle A and angle D will be supplementary. So let's write that down. So that will be angle A plus angle D is equal to 180 degrees supplementary. So this let's write as the third equation. And why are they supplementary? They're supplementary because co-interior angles are supplementary. So now again, let's go back to equation 1. Okay, we're going to use equation 1 here. Here, what does it say? Angle A is equal to angle B. So in the place of angle A, we're going to write angle B. So this would be angle B plus angle D is equal to 180 degrees. So angle B plus angle D, this is B and this is D, they are opposite angles. So we have proved that they are also equal. So we have proved the second part. So here also we have proved. So what have we proved here? We have proved that in an isosceles trapezium, the opposite angles are supplementary. So we can write that. So we have proved that they are supplementary. Question 12. ABCD is a parallelogram. Now, what kind of a quadrilateral is it if AC is equal to BD? Now, AC and BD will be the diagonals of this parallelogram and AC is perpendicular to BD. Okay, so let's write what's given first. So we've given that the diagonals are equal, they're perpendicular to each other. Diagonals of the quadrilateral are equal. Okay, then here again we have the diagonals and they bisect each other at right angles. When you say they're perpendicular, that means they are meeting at right angles at 90 degrees. So when diagonals are equal and they intersect, okay, at right angles, then that figure is a square. So we have a square here, as you can see, AC and BD. These are the two diagonals. They are equal. The measurement will be equal and they are also perpendicular to each other. That means they form an angle of 90 degrees. So such a quadrilateral is called a square. Second one, what kind of a quadrilateral is it if AC is perpendicular to BD but it's not equal to it? They're perpendicular but they're not equal. So given is this, that is AC is perpendicular to BD. That means they intersect at 90 degrees but they're not equal in length. So if they're perpendicular, that means the diagonals are bisecting each other at right angles, isn't it? Then AC is not equal to BD. So if you have diagonals that bisect each other at right angles, but at the same time the diagonals are not equal to each other, such a figure is known as a rhombus. We call it a rhombus. So diagonals meet each other or intersect each other at right angles, but they are not equal. So this is a rhombus. That's a rhombus, as you can see. So here we can see that AC. Okay, now if we have to name it, we have AC and BD and their diagonals. They are not equal in length. The length is different. They are not equal. But as you can see, they are meeting each other, intersecting each other at right angles. That means they are perpendicular to each other. So this is a rhombus. Now this time AC is equal to BD but AC is not perpendicular to BD. So what kind of a quadrilateral is it? So given AC, the diagonals are equal but they are not perpendicular to each other. So when the diagonals are equal and bisect each other, so this is the first point, the diagonals of the quadrilateral are equal and they bisect each other but they are not perpendicular to each other. Okay, it's given that they bisect but they are not perpendicular. It is a rectangle. Let's have a look at this rectangle. So here can you see the diagonals AC and BD? They're equal, but they're not perpendicular. They are not meeting at right angles. So such a quadrilateral is called a rectangle. Question 13. Prove that the diagonals of a parallelogram bisect each other. So here we have a parallelogram. We have the diagonals AC and BD and they are meeting at a point O. So what is given to us? A parallelogram whose diagonals intersect at O. The diagonals are intersecting each other here. Then what do we have to prove? We have to prove that these diagonals are bisecting. You can see it bisecting. Now we need to prove it. Now let's begin the proof. Now let's look at these two lines AB and DC. Okay, they are parallel to each other. So let's make a note of that point. AB is parallel to CD. So these are two parallel lines. This is one and this is one. And if we consider BC to be the transversal that is cutting the two parallel lines, let's consider that. So BC is the transversal, okay, cutting the two parallel lines. So in that case, the angles that are here and here, that is the angles that are marked in red, let's name them. Let's name them as angle BAO. Now BAO will be equal to angle DCO. So let's write that will be equal to angle DCO. And what is the reason? They will become interior alternate angles, isn't it? When you take AB and CD as the parallel lines, BC as the transversal, these two will become alternate angles. That's why these two angles are equal. So the reason is alternate angles. Now let's once again consider AB and CD as parallel lines, and this time take AD as the transversal. So this time when we take AD as the transversal, what do we see? We see that two angles are equal to each other. Which two angles? That is this angle here and this angle here. And how are they equal to each other? Again, when the parallel lines are cut by this transversal, these become alternate angles. So alternate angles are equal. So let's write that also down. That will be angle ABO is equal to angle CDO. And what's the reason? Again, they are alternate angles. Now let's look at sides A, B and CD. Sides of a parallelogram are equal. The opposite sides of a parallelogram are equal. So we can write that down. We can write it as AB is equal to DC. And what is the reason? Opposite sides of a parallelogram are equal. Okay, so let's mark that also. So these opposite sides also are equal. Now can you see these two triangles, triangle AOB and triangle COD? They are congruent angles. Why are they congruent? On the basis of angle, side, angle. Here also angle, side, angle. We can say that these two triangles are congruent triangles. So let's write that down. That is triangle AOB is congruent to triangle, so let's write that properly, triangle COD. And what is the reason? Corresponding, this is on the basis of angle, side angle, and because of that corresponding parts of these two congruent triangles will be equal. Okay, so first AOB is congruent to COD. These two are congruent on the basis of angle, side angle. And because they are congruent triangles, the corresponding parts will be equal. That means OA, that is here, OA will be equal to OC and OB will be equal to OD. So let's write that. OA is equal to OC and OB is equal to OD. Okay, and how did we get this? We got this because corresponding parts of congruent triangles are equal. That's why we say this. So that means we have proved it, isn't it? We have proved that they bisect each other because they are equal. Both sides are equal here. Corresponding parts are equal. So we say that these diagonals have bisected each other and hence we have proved it. Okay, so to prove it, these are all the steps you need to follow and at the end you have to say that you have proved it. Question 14. If the diagonals of a parallelogram are of equal lengths, the parallelogram is a rectangle. Now we have to prove it. So what's given to us? ABCD is a parallelogram whose diagonals are of equal lengths. So here we have a parallelogram ABCD and the diagonals are of equal lengths. It's given to us in the question. Now what do we have to prove? We have to prove that this parallelogram is a rectangle. Now to prove that this is a rectangle, one very important property about rectangles is the angles that are formed, the four angles are of 90 degrees. So if we can prove that the angles here are 90 degrees, then we can say that this parallelogram is a rectangle. So for that, first thing we're going to do as proof is we're going to look at triangles, two triangles. One is triangle ABC and the other is triangle ABD. So we have triangle ABD, that is this triangle, and we have the other triangle, that is angle ABC, that is this triangle. We're going to look at these two triangles. So let's write that. In triangle, what are the two triangles we have taken? ABD. So we have triangles ABD and triangle ABC. ABC. We're going to look at these two triangles. Now in these two triangles, these two sides BC and AD are equal to each other. Okay, so let's write that. BC and AD are equal to each other. So BC is equal to AD, and what is the reason for this? Opposite sides of a parallelogram are equal. That's how we got BC is equal to AD, because they are opposite sides. So these two sides, let's mark them. These two sides are equal. Now look at the side AB. Look at the side AB. This side AB is common to this triangle as well as to this triangle. It's a base of both the triangles, isn't it? So we can write that next. We can say AB is equal to AB itself. And what's the reason? They are common. So we can mark that here. And then we can also say that AC is equal to BD. Now, how do we know that? It's given here? The diagonals of the parallelogram are equal and these are diagonals. So AC is equal to BD and we can write that. So AC is equal to BD and this has been given to us. So if we mark that here, so here also we have these two sides that are equal. So now so far we have AB that is common, we have AD and BC that are equal to each other, and we have the two diagonals that are equal to each other. Now we can say that these two triangles that we have marked here are congruent on the basis of what? Side, side, side. On the basis of that, we can say that these two triangles are congruent. So let's write that. We can say triangle ABD is congruent to triangle ABC. And on what basis? On the basis of side, side, side. So since these are congruent triangles, we can now look at the angles. So if you see angle A here and angle B are equal, we can consider them to be equal because congruent parts corresponding parts of congruent triangles are equal. So these are corresponding angles. We can say angle A is now equal to angle B. Now how can we say that? Corresponding parts of congruent triangles are equal. These two triangles are congruent, so the corresponding parts will be equal. So angle A is equal to angle B. Now remember, we are trying to get 90 degrees here, isn't it? We are trying to get 90 degrees here and here. So we are working out everything to get that. Now let's look at AD and BC. They are two parallel lines, isn't it? So let's write that AD is parallel to BC. So in that case, if you take AB as the transversal cutting the two parallel lines, angle A and angle B together will add up to 180 degrees because they will be co-interior angles or allied angles. So if you take these two parallel lines, then in that case, angle A plus angle B will be equal to 180 degrees. Okay, because they are co-interior angles, they'll become equal to 180 degrees. Now here what we can do is to find this angle. Instead of writing B here, we can write A. How can we write that? Because here it says B is equal to A. So we can write that. We can substitute and say angle A plus angle A. We are writing A again because B is equal to A. So that is equal to 180 degrees. So now we can continue and try and solve this. So this will be 2A. 2 of angle A is equal to 180 degrees. So angle A alone will be 180 degrees by 2, which is 90 degrees. So if angle A is 90 degrees, we can write it here. So we have proved that this part is 90 degrees. And here we have already said that angle A is equal to angle B. Here also it is 90 degrees. So here it is 90 degrees. So here, since we have 90 degrees here, we have proved that the parallelogram is a rectangle. So we can say hence proved. Question 15. In parallelogram ABCD, E is the midpoint of AD. So we should get a midpoint here. So we have a midpoint here, AD, and E is the midpoint of AD, and F is the midpoint of BC. So F is the midpoint of BC. Now we have to prove that BF, okay, now we have BF here, DE. BF and DE. BF, DE is a parallelogram. So we have to join these. So when we join these, we get this. Okay. So we have to prove that the figure that we got here is a parallelogram. So what is given to us? ABCD is a parallelogram in which E is the midpoint and of AD and F is the midpoint of BC. Now we have to prove that BFDE is a parallelogram. So let's begin the proof. Let's begin by looking at this side. Since E is the midpoint of AD, DE, we are looking at this, isn't it? DE will be half of AD. DE will be half of this because it's a midpoint. So let's write that. So DE will be equal to half of AD. The whole line is AD, and because we have the midpoint, DE will be half of it. Similarly, on the other side, since F is the midpoint, this will be half of, that is BF will be half of BC. So let's write that BF will be equal to half of BC. So let this be equation 1 and let this be equation 2 because we're going to be using it later. Now let's look at these two sides, AD and BC. They're equal to each other. That is, let's write that AD is equal to BC, AD is equal to BC. Now how do we know that? We know that because opposite sides of a parallelogram will be equal. So AD is equal to BC. So that also means that if we take half of AD, that will be equal to half of BC. And how much, what is half of AD? DE. What is half of BC? BF. So we can write that. That means DE is equal to BF. So this is the third equation. Now we need all these. So let's keep all these carefully because we'll be using it later. Now look at these two sides. AD and BC, they are parallel to each other, isn't it? If they are parallel to each other, then ED is also parallel to BF. So we can write that. So let's write that now. That is AD is parallel to BC. That means ED also, ED is parallel to BF. So here we have made use of all these equations here. Half of AD is DE, we have written here. Second equation, half of BC is BF, half of BC is BF. Now here we have DE is equal to BF. And now we've also shown this that they are parallel. So this is the fourth one. So now if you look at points 3 and 4, equations 3 and 4, where we say DE, third one, what does it say? It says that DE is equal to BF. And what does the fourth one say? ED or DE is parallel to BF. So we have got that two sides are equal and those two sides are also parallel. When you have such a figure where you have two sides that are equal and those two sides being parallel, then that is a parallelogram. Hence, we have proved it here. So hope you have understood. Use all these as substitutions here and finally arrive at your answer here and say hence proved. So with this children, we have come to the end of this exercise. Thank you children.